Lesson 10 of our math books. Warm up 10.1, angles of an isosceles triangle. Reflect triangle ABC over line AB and label the image of C as C prime. Here's my triangle ABC. Reflect it over line AB and label the image of C as C prime. Hover my pencil. I'm going to get a straight edge, but I don't have one handy. There we go. Connecting C prime to A and B. So C prime. Okay. Rotate triangle ABC prime around A so that C prime matches B. ABC prime. So that C prime matches B. So this would now be B prime under a rotation around A. What can you say about the measures of angle B and C? Well, when I rotated it, so here is angle C prime. And when we rotated it, C prime and B have the same measure. So the measure of angle C would also be the same as B because C and C prime are the same angle. Just in case you don't know, the date today is 9/24. Okay. The measure of angles B and C. Because under our rigid transformations, angle C prime mapped to angle B. All right, next question. You're on 10.2. Here is triangle ABC. Draw a midpoint M of AC. So midpoint is halfway in between, so I'm going to measure it. I have a little dot on my trace paper. I'm going to fold that section in half. And that's going to give me my midpoint. So I'm going to line my point back up with C. There's my midpoint. Labeling it M. 2. Rotate triangle ABC 180 degrees using center M to form triangle CDA. Okay, so BAC 180 degrees. Remember, the direction doesn't matter for 180 degrees. That would be 90. There is 100. So I'm going to hover my pencil over point B. And we now have triangle, that would be C prime. We're not making, so we have C, this would be D, A. I use my straight edge to connect them. Oh, it says draw and label this triangle. So we have it drawn and label. Question 3, what kind of quadrilateral is ABCD? Well, this is a parallelogram. Parallelogram is made up of two identical triangles. And we know these are identical triangles because we did a rigid transformation of 180 degrees. So line BC and AD are parallel. So we have BC is parallel to AD and AB is parallel to CD. .3. The picture shows three triangles. Triangle 2 and 3 are images of triangle A under a rigid transformation. Describe a rigid transformation that takes triangle 1 to triangle 2. What points in triangle 2 correspond to points or 2 points A, B, C in the original? So triangle 1 is almost the same as the last question. So we can do a couple different moves. But we just saw on the page before that when we had our AC and we took that midpoint, it made the triangle on the top. So if we take a midpoint here, there's our midpoint because that's down 1 over 1, down 1 over 1. So we're going to label it M. Using midpoint M, rotate 180 degrees. Okay. When I rotate 180 degrees, A is now C. B is now D. And A is now C. Sorry. A was C. B was D. C is A. I went in the wrong order. And C moved to A. So these two just flip-flopped, and then B became a new point. Describe a rigid transformation that takes triangle 1 to triangle 3. So we need to go from here to here. Looks very similar to this first move. What if we took this, a midpoint between here? This one cuts directly through 2, so we're going to do midpoint N, and let's see if that works. There's 90. There's 180. Okay? So we're going to write that. Using midpoint N, rotate 180 degrees. Okay, so A became B. B became A. And C became E. Find two pairs of line segments in the diagram that are the same length, and explain how you know they are the same length. Well, we can do line segment AD is 1, 2, 3, 4, 5, 6 units long. Segment BC is 1, 2, 3, 4, 5, 6 units long. We know they are the same because we counted them, but they are also images of one another because triangle 1 is our original and 2 was created using a rigid transformation. So we can say they are the same length because rigid transformation does not change your shape or your image. And it says two pairs, so another pair would be AB and CD. AB is equal to CD, and the same reason. Find two angles in the diagram that have two pairs of angles that have the same measure of angle. So angle ABE and angle BAC. And we also have angle BEA and angle CAD. Both these angles. And it's the same thing. So I'm going to write reason. Whoops. is that same reason. We know they are the same because rigid transformations don't change your image. Alrighty, 10.4. Here's an isosceles triangle, ONE. On side ON and OE have equal lengths. So if this is 5, this is 5. Angle O is 30 degrees. The length on ON is 5 units. Oh, that told us. Last question, 10.4. Here's an isosceles triangle, ONE. On side ON and OE have equal lengths. And angle O is 30 degrees. The length of ON is 5 units. 5 units, 5 units. Reflect triangle ONE along cross segment ON. And label the new vertex M. So trace it first. And we are reflecting it across ON, which is this line right here. Hover your pencil. And then we have point M. What is the measure of MON? Well, along a rigid transformation, our angles do not change. So this is still 30 degrees. What is the measure of MOE? So this whole angle. We have 30 degrees plus 30 degrees would be 60 degrees. Reflect triangle MON across OM. Label the point corresponding to N as T. So we're going to reflect across this line. Hover the pencil. That is now T. How long is OT? Well, originally it was, so I reflected it backwards again. It was ON, and ON is 5. So that means OT is 5. Because rigid transformations were done, the side length will not change. What is the measure of angle TOE? Well, this one is 30, and this one is 30, and this one is 30. We have 90 degrees. If you continue to reflect each new triangle this way to make a pattern, what will the pattern look like? The pattern will look like a... Complete the pattern, figure out what it does, and the last question of your video is fill in the blank. What does it look like?